This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
The moment Dario Amodei called the current AI uproar a crisis of trust, the room fell silent and then erupted, all at once. What if the very thing that's holding back the next wave of breakthroughs is something we can rebuild, piece by piece, with the same technology that sparked the panic? We're standing at a crossroads where the promise of language models collides with a public that feels left in the dark. In the next few minutes, I'll walk you through why that distrust grew, how the backlash is structured, what Amodei really means when he warns us to slow down, why transparency alone isn't enough, and finally how a decentralized inference network like ChainMind can flip the script from suspicion to confidence. By the end, you'll see a concrete roadmap for a future where AI is not just powerful but provably trustworthy. First, let's unpack the trust deficit that's been gnawing at the industry. Large language models have been rolled out at breakneck speed, sometimes in a matter of weeks from research paper to public API. That velocity is impressive, but it also means that the usual checkpoints, public scrutiny, peer review, even basic user education, have been bypassed. Companies rarely reveal where their training data comes from, how they filter it, or what fine-tuning objectives they use. When a model suddenly generates a hateful slur or fabricates a convincing but false news story, the headlines scream AI gone rogue, while the underlying pipelines stay hidden. Add to that a wave of layoffs blamed on automation and a patchwork of half-baked regulations, and you have a perfect storm for eroding confidence. People start to wonder, if the creators can't explain how a model works, how can anyone trust what it says? Understanding the anatomy of the backlash helps us see why it feels so relentless. It's not a single voice, but three overlapping layers that amplify each other. The media latches onto sensational examples, deepfakes that mimic politicians, chatbots that spew extremist rhetoric, and spreads them faster than any technical rebuttal can catch up. Meanwhile, the research community, in an effort to be responsible, publishes red team analyses that expose vulnerabilities but often stop short of offering clear fixes. Finally, policymakers, reacting to public outcry, draft bills that swing between heavy-handed bans and vague mandates, creating a legal gray zone that scares investors and slows development. The loop is simple. Alarming stories fuel public fear, fear pushes regulators to act, and restrictive policies make it harder for developers to demonstrate responsible innovation. Breaking that loop requires a new narrative, one that shows we can be both bold and accountable. Amodei's perspective is often painted as pessimistic, but if you listen closely, it's actually a call for constructive caution. He argues that the trust crisis isn't a result of malicious intent, it's the byproduct of an industry that assumed internal safety checks were sufficient. Private audits, proprietary guardrails, and closed-door safety teams might keep a few bugs at bay, but they don't satisfy external stakeholders who can't see the work happening behind the curtain. Critics worry that his warning will stall investment, that a focus on risk will choke the creative energy that fuels AI breakthroughs. Yet Amodei counters that a false sense of security is far more dangerous. He envisions a future where the cost of ignoring trust gaps manifests as draconian regulations, a loss of user engagement, and a talent drain toward more open ecosystems. In his view, the short-term slowdown is a small price to pay for long-term stability and growth. But here's the part most people get wrong. Transparency alone won't solve the problem. We hear a lot of talk about open model cards and explainability tools, and those are essential steps, but they're only pieces of a larger puzzle. Transparency has three dimensions that matter. First, data provenance. Knowing where the raw text, images, or code came from lets users assess bias and privacy risks, but companies guard that data fiercely because it's also a competitive advantage. Second, model interpretability. Tools that show attention maps or token-level attributions can demystify a black box, yet they often require specialized knowledge to interpret correctly. Third, governance reporting. Regular safety audits, incident logs, and remediation timelines signal accountability, but they demand a culture of openness that many firms haven't yet adopted. The challenge is that full disclosure at the scale of today's LLMs is technically daunting. Incremental moves, publishing model cards, releasing benchmark suites, inviting third-party red team audits, are practical compromises that show intent without spilling trade secrets. Still, without a structural change in how inference is delivered, even the most transparent model can be wielded in ways that undermine trust. That structural change is where decentralized inference steps onto the stage. In a traditional setup, a handful of cloud providers own the hardware, the software, and the data pipelines. All the computation happens behind their firewalls, and the user's request is a black box transaction. Decentralized inference networks flip that model on its head. Imagine a global ledger where each inference request is logged, each node that processes the request is identified, and every step is cryptographically verifiable. When a model runs on chain mind, the computation is spread across a diverse set of participants, individuals with spare GPU capacity, edge data centers, even community-run clusters. This architecture brings three concrete trust benefits. Auditability becomes real. Anyone can trace a specific output back to the exact nodes that performed the calculation, and the immutable record prevents tampering. Resilience improves dramatically. There's no single point of failure that could be compromised or shut down, so malicious actors find it harder to disrupt service. And economic inclusivity spreads the upside. People who previously had no stake in AI can earn fees for providing compute, diluting the concentration of profit that fuels suspicion of monopolistic control. By aligning the incentives of developers, users, and independent operators, a decentralized network embodies the transparency, accountability, and shared responsibility that Amadei calls for. From a policy standpoint, this shift also reshapes the conversation with regulators. Instead of reacting to crises with blanket bans, governments can adopt a risk-based licensing framework that distinguishes low-impact uses, like drafting emails, from high-impact scenarios such as medical diagnosis or legal advice. Safety standards consortiums can draft technical specifications that are then referenced in legislation, ensuring that rules are technically feasible and not just punitive. Incentivized openness, through tax credits, grants, or public-private partnerships, can reward companies that publish model cards, open-source safety tools, or participate in public red team audits. When the infrastructure itself is transparent and auditable, regulators gain a reliable data source to monitor compliance, and developers gain clearer guidance on what is required to stay within the law. The result is a collaborative ecosystem where AI is seen as a shared responsibility rather than an existential threat. Putting all of this together, stakeholders have a practical checklist they can start using today. First, publish a model card for every release, detailing data sources, known limitations, and fairness metrics. Second, set up continuous red team audits with external safety labs and share summary findings publicly. Third, roll out explainability APIs that return attention maps, token-level attributions, or confidence scores for any given output. Fourth, experiment with decentralized inference for high-stakes applications, leveraging platforms like ChainMind to make the computation path visible. and immutable. Fifth, maintain a public incident log that documents harmful outputs, the remediation steps taken, and the timeline for resolution. Finally, engage the broader community through webinars, Q&A sessions, and hackathons focused on safety tooling. By institutionalizing these practices, companies move from crisis management to proactive trust cultivation, turning transparency into a competitive advantage rather than a regulatory burden. The story we're writing right now isn't just about AI's next breakthrough, it's about the social contract that lets those breakthroughs thrive. Anthropic's CEO may have sounded a warning, but the warning is also a blueprint for rebuilding that contract. Decentralized inference, transparent governance, and collaborative policy design together form a trust architecture that can turn today's skepticism into tomorrow's confidence. Companies that seize this moment will not only survive the current wave of backlash, they'll set the standard for a trustworthy AI future. If you want to be part of that future, keep an eye on the networks that are redefining how we run models. Follow ChainMind, watch the experiments, and join the conversation about how decentralized inference can make AI safer, fairer, and more accountable for everyone. The next chapter of AI is still being written, and the pen is in our hands.